Hi everyone, we're going to graph a pair of parametric equations. We want to eliminate the parameter, actually t, to obtain a rectangular equation by solving for it and then substituting it into the other. We may need to adjust the domain of the resulting rectangular equations to match the restriction of the original parametric equation. So let's just talk about that first. First of all, t is all possible real numbers. So any real number I put in this first equation here, so if I put in -2, that's going to be positive because that's going to be 4. So basically x is always going to be greater than or equal to 0. So it's positive including 0. So that's, I'm restricting my x here to be greater than or equal to 0. And also we're going to have that y, look at this, since x has to be greater than or equal to 0, y has to be greater than or equal to 3. Because if I plug in 0 here for the t, then I'm going to be starting at my y-intercept, which is 3. So let's just look at this. So first of all, I'm going to just use substitution. So I have t squared here and t squared there. And I'm going to substitute and put the x in there. So I get y equals 2x plus 3. And x has to be greater than or equal to 0. And that's your answer. All right, and so when you're graphing it, here it is. We have to restrict given the parameters, and x has to be greater than or equal to 0. And then I just went up 2 over 2, up 2 over 1, up 2 over 1 like that, and graphed my equation. All right. The next video we're going to talk about is the orientation of the graph of a parametric equation, because we want to know what the direction of the graph is. Thank you and have a nice day. Bye-bye.